Okay, yesterday we already looked into how you're going to convert the number to the BCD code, any number. So any number you're going to convert to BCD code. What you need to do is you just need to convert the number into the binary. So this is the representations of the codes. Of the codes. This is the number that were given. Same goes to here. This is number that given, and you're going to see you have the BCD. And yesterday we have two methods, and maybe if you are a kind of person can understand this, you can memorize like this one and another one, but I prefer for you to like just go to the examples, then you can see, oh, this is the method. If you need to convert the binary to gray code, what you need to do, like adding things for your binary numbers. And please make sure you remember the tables I give you already since our second class, I guess. So you will have like this table, 0 plus 0, you will get 0, 0 plus 1, you will get 1, 1 plus 0, you will get 1. And 1 plus 1, normally this one is, if in decimal, you will get 2, but in binary, you will get 1, 0. This is your sum, this is your sum, this is your sum, this is your sum. This is your sum. And the one in front is carry. So this is sum. And you're going to have from here your MSB is directly going to go down, which is you will maintain the MSB. And next you're going to add these two numbers. And the answer for the sum you will bring down to your gray code. So this is what happened. You will add 1 plus 0, you will get 1 as the sum. And then you add another 0 plus 0, you will get sum 0. And 0 plus 1, you will get 1 as the sum. 1 plus 1, you will get sum as 0, carry as 1. So in your gray code, although you need to convert from binary to gray code, you need to discharge carry, or maybe from gray to the binary code, you need to also discharge the carry. And over here, you will have 1 plus 0, you will get 1 as the sum. And then 0 plus 1, you will get 1 as the sum. And 1 plus 0, you will get 1 as the sum. So this is how the gray code after you convert from your binary. Next example is the one for you to convert the gray code to your binary. So it is slightly different, but there is several things that maintain, which is MSB will be maintained, which is similar to previous methods, and every carry you will discharge. So you're going to bring it down, this MSB value, and in the previous method, you're going to do like this adding thing, which is you're going to add the binary numbers. But what you're going to do for convert gray to binary, you're going to do the zigzag. As I mentioned yesterday, it is a zigzag things. This one, you will bring it as a 1. And this value you will add with the gray code. So you will 8. 1 plus 1, again, your sum will be 0, your carry will be 1, this will be discharged. This is your answer for the sum. So you put it below here. And you bring this answer for the binary, you bring and add to your gray code. So this is how it look like. And you add another one, you will put all here is as a sum, similar as a previous. Why my WhatsApp group is very active today? Let me vibrate only. Okay, so it's continue. Okay, here you add 1 plus 1, you will get 1 0. This is your sum, this is your carry. So just that. So it's very easy. There is no trick and there is not tricky at all. You can try the exercise that given. I do believe that in your module also it provided you with several example and several exercise. Now this is the new subtopic. We're going to go into parity code. Parity bits are used for bit error detection. Sometimes when you want to convert whatever numbers, also you might also find an error. So our parity, even parity, total number of ones is even. Means let's say, means let's say if you have a number. Ui, mak kau meletup. Apa ni? Okay, if you have that events, of course it's going to be very smart. Even will be so nombor genap and nombor ganjil, I guess for international student, you know that even is what, odd is what. So if let's say I have a number like 1, 1, 0, 1. So we call, if let's say this is your parity code, okay, you're going to have 1, 2, 3. 3 digit 1. 3 digit 1 it's mean as odd, right? So it is odd parity. If I have 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 1. I have total as 4 bit of 1. So it is even. So now it is a even parity. It's easy, right, for you to understand because it's already mentioned and you just need to calculate how many bits ones that you have. And okay, over here you have parity bits is append to the code at the leftmost positions MSB. So normally if you want to play around with later on your sign magnitude which is 0 or 1, you will look into the MSB side. So parity, you can write, you can read all of this. I will like directly go to your example here. Okay, you need to remember the example here, which is basic rules. If let's say you have a even, your first number is like 1 or 0, and you have even number, so you're going to have even parity as 0. Let's say I have example 101, and your first MSB, let's say it is an odd number, so it is odd parity, you're going to have 1. But if let's say you have this one is even, because you have total is 1 2. See, 1 2, you're going to see whether your first one is even or odd. 101, you have 2 of 1, you call as your first number is even. So even you're going to look into here whether your first value is 1 or your value is 0 in front. So you're going to see if your value at your MSP is 1, then it's an odd parity. If let's say, because this is even first, right, first number, which is digit 1, you're going to see if let's say I have this kind of number, your MSB will be 0 in front, and your number digit 1 is even, so it is even parity because you are at here. If let's say you have another example where we look into odd, if we have 1101, we have 3 digits of 1. So over here, we're going to see that it is under odd. But of course, you need to see at your MSB part. If it is 1, then it is even parity of 1. If it is odd, it's going to be 0. If it is 0, it's going to parity, odd parity. So that is the rules. Maybe you need to remember this table so then you understand. But we take a look into example here. We have even parity 1 2 3 4 5. Even parity, this one, and we have one. Wait, someone want to join us. Okay. Okay, example, if let's say you have one, where is my pen? You have 101001110. 1 2 3 4 5. It's going to be odd. Your number is odd, isn't it? So you have the numbers of 1 as odd, which is ganjil. After that, you're going to look into the first MSB side. It is 1. So you will notice that it is even parity. So in front of your even parity, you need to put 1. Just to make sure that you're going to convert it to be even parity. But when you read of this number, example of this number, you will notice that you have what 1, 2, 3, 4, 5, which is odd, is a nombor genap, and you look numbers of odd over here, and in front of it, it is digit 1. It's going, sorry, this one, MSB, it is a even parity. If you want to play around with even parity, or maybe you were given only these numbers, and then it mentions you need to change it into even parity, then you need to know in front of the number should be is 1. This is also 1 for the even parity. If let's say you were given this number and you need to change to odd parity bits, 1, 2, 3, 4, 5. 5 is odd. Look into odd, similar to this one, odd, and you need to go for the odd parity bits. You need to convert this number to odd parity. Then you need to see this one, odd parity, your MSP will be 0. Then you need to put 0 in front as your odd parity code. So if let's say you have 1, 1, 0 as a number, and you know this is your even. If let's say for even, you're going to look into this even side, and it asks you, let's say, convert it into even parity. So even parity is 0. Convert it into odd parity, you need to put 1. So that is on the parity codes here. On the even parity or odd parity, it is depend on your numbers of one digit in your question given. Please make sure you remember this table. You have 7 bits of numbers. So numbers of 1, you need to calculate. Let's say over here you have 1, 2, 3. So the number of 1 is 3. Number of 1 is 4, and number of 1 is 7. And when you want to change to parity, you're going to have 8 bits because you need to add another numbers in front, isn't it? If let's say over here you have 1, 2, 3. For 3, it is a odd number. If let's say it odd, please make sure you remember odd. If you want to have even parity, you have 1. If you have odd, you have 0. Odd number, if you have odd, it is 0. If you have even, you have 1. Similar to this one. This one is 0. It is your even number. For even number, go back to take a look into this table. For even number, if even parity, you need to add 0. Odd parity, you need to add 1. And this will be similar to this part because it is a even number for bits 1. And you add 0 for even, 1 for odd. And this will be similar to this one. So that is how, if you have a number and you want to convert it into evens of or your odd parity. And in front of all these numbers here, it is not the value. Instead, it is just like a code for you to represent the parity bits. So normally in equation, of course, you might like confuse. This number is the value of binary, or is it this is a parity code. So don't worry about that, because in every question you will be given all the information, including like 7 bits and then 8 bits here. So you just need to see, okay, this is 7-bit number. If you want to convert to parity, of course you will add another another 1 bit. So if let's say you have 8 bits, if you want to convert to parity, you have 9 bits and etc. So there is another example. Let me charge my battery. Okay, in this example, it asks you to calculate the parity bits for the codes below. Where is my charger? Okay. Let's say you were given with the numbers that provided here. Let me draw. Forgot the table. Even, parity, odd, even, odd. Okay, calculate the parity bit for the codes below. First, you need to see that how many bits number that you have. 1, 2, 3. You have 3 numbers of bit 1, and it's going to be an odd. Let me see over here. This is my odd part. If it is parity of even, I need to add 1 in front. If it is odd, I need to add 0 in front for become as an even parity or odd parity. So second example here, I have 1, 2, 3, 4. 4, it will be even. For even, I need to see this part. Even, I will add 0 for the even parity and 1 for the odd parity. This one I have 2, so it's similar to above, which is even number. So I will look into this table, which is I will add 0 for even parity and 1 for odd parity. So this is how it's going to be. There is no like method for you to memorize, but you need to memorize this table. Need to remember the table. I also did remember this. I have I have reason because of my age, but you don't have any reason to give to me why you cannot remember this table, because you're still young. Okay, now you can see over here you have error detection by parity checking. Assume that data is 0, 1, 0, 1. It use even parity. It's already given you, okay, this is even parity. This is what number? This is even numbers. Therefore, the appended parity bits will be 0, because you have even, 0, 1, 1, 0. So if let's say you want to have even parity, you need to add 0 in front. So your number will be 0. The data with the parity bits will be 0, 0, 1, 0, 1. The data is transmitted. The data is received as 0, 0, 0, 0, 1. Odd number of ones, not even. Huh? Sorry, I make you confused at this part. Okay, when you transmit letter, you if let's say you have point A, and then you have a point B, which is you're going to have transmitter and also receiver. If you want to send, let's say you want to send a data with this number to another point, so your data is this, but when you have an even parity, you will have 00101. And you're going to see when you transmit, then your data that you receive at point B is 00001, which is you're going to see it is even, but does not confirm to even parity yet. This is like you want to check an error. Sometimes whenever you want to transmit anything, let's say I want to send okay, the very good example, let's say you normally you watch the, I think Instagram video or YouTube video or Facebook video, when there is a first person, if here given any instruction, let's say selamat pagi, or maybe whatever instruction to this first person, when you transmit, go to until your last person, you will get like totally sometime different with the first instruction given. So same goes to whatever, let's say we send our data to from one base station to another base station, or maybe we just transmit from our phone to our computer. So there is also some like packet loss and etc. So this is on how you're going to detect an error detection by using your parity checking. So this is just a scenario for you to see. You can see the data is received at 00001, which is it is a odd number of 0 and not even like before. So but this is how basically when you have an error detection, although you know that this is basically your answer, which is your data, when you send, you're going to have like a different number. That's why if let's say you receive the data over here, it is not similar, so the odd number is not an even. So this is mentions that there is an error detection when you play around with the parity checking. I guess you can also look into your module later on. There is also several explanations. If you, let's say, want to see into the error detection by using this parity checking. But as long as you know and you remember this table, you can easily convert from any bits data that given, and you can provide with the even parity or odd parity for that specific number given, similar to also this example. Okay, so next basically yesterday we want to finish this ASCII code, right? but but yesterday we didn't have time to finish, so this is the one that you need to know the tables for ASCII. It has 128 characters and symbols represented in 7-bit binary code. So you need to remember the sentences, although I don't like to read, but this is all the keyword that you need to remember. 128 character, and it is supposed to be 7-bit. So example here, you have and A small, A capital letter and small letter. So these two, you're going to have the binary code with different kind of codes. Although, yeah, in our like daily life, oh, this is A. This is similar because it is A. But when you want to apply into like a computer system, they don't know basically this A is similar. They need to also differentiate in terms of like capital letter, small letter. So that's why the code also different. A parity bit is added so that the total number of bit is 8. So you're going to add, if let's say you want to convert to the using the parity bits, you need to add 1 bits in front. So it's depend on the code itself. But let's take a look over here. You were given the table in your test, in your final exam. If you were given with the ASCII question, normally we will provide you with the table depending on which part that we want to ask. Maybe only these 2 tables, but sometimes we just give you the whole table for ASCII. So you're going to see, let's say, we have the decimal number here. We have all together from 0 to 128. All together, we have 128 numbers or characters. And you can see over here from 0, let's say this example, our hexadecimal is what, and this is our ASCII code. Whenever you see like this, right, when you enter 0 in your, let's say, a computer, so what is the code that you basically provide to your computer is 48. Or in a binary, whatever, maybe you can try to convert to binary. This is just your hexadecimal, but of course, as mentioned, your computer only know 1010, so you need to convert it. But this is just a representation. Now you can see A is what in decimal, in hexa, but for the small letter, it will be 61 for 61 for hexa and 97 for decimal. And you also can see there is a symbol inside our ASCII code, and those symbols also represent the decimal value and hexadecimal value. This when you have 7-bit binary and you have the ASCII code, you're going to see for this part, okay, you have 0, 1, 2, 3, 4, 5 until 7 bits. And over here, this is a row. If you have a 7-bit, basically what is possibilities that you will have, you can see the bits over here. Bits 1, 2, 3, 4, 5, 6, 7. Let's say you have the value of 0, 1, 0, 1, 1, 0, 1. 1, 2, 3, 4, 5, 6, 7. Okay, this is 7-bit binary. And you want to convert to your ASCII code. What is the ASCII code? So for these 7 bits, let us see where is it. First, we will see the first 4 bits at this table. This one is 1, 2, 3, 4 until bit 7. So we will see this part 1101. 1101. we will look into this side, and our above side will be 0, 1, 0. 0, 1, 0. Instead, this long binary, which is the one that your computer know, we just press the dash here in our keyboard. Instead, whenever we press this dash, our computer will read like this. So this is one example. Let's say you have a different kind of number. Let's say I put 0, 1, 0, 1, 1, 0. Okay. So we have over here 0, 1, 1, 0, 0, 1, 1, 0. And this part is 0, 1, 1, 0, 1, 1. So let me see. Okay, it is represent as C for my ASCII code. So this table, of course, you cannot remember. So as usual, as I mentioned, if we going to ask you this kind of question, which is you need to convert the binary to ASCII, we provide you with the table. So there is no just thing for you to remember all the value here and all the table inside. So no need for you to remember the table. Here is give you the example, quite similar to mine. Let we see, this one is 1101, 1101, and 110. So it's as a represent as M. So when you press M on your keyboard, let's say this is your computer reading, because as I mentioned, your computer only know the binary code. Is called as a machine language. Okay, you were given with the exercise. Instead of you were given with the value of like binary, you need to find out the ASCII. Similar to our previous like subtopic, you will also have the vice versa. So in this one, you were given SCR 1013 to ASCII hexadecimal. So this is the string for your ASCII, and you need to convert to hexadecimal value.
It's 9 hours.
Where is the one that is given? So you need to refer this table. Let we copy paste over here and try. Okay, we have we have S. We have S, and our hexadecimal is 53. We have C. Where is C? Capital letter 43. We have R 52. We have 1 31. We have 0 30. 1 is 31, and 3 33. So from your SCR 1013 ASCII, you can convert it into hexadecimal by using this table. As I mentioned, no need for you to remember. Of course, If you are Kyle as well, try to find this movie. I think it is not movie, drama series. Maybe your versions of Jen didn't know about this drama, but I love the look of the hero and the heroine. Uh, she have very like pure face, very soft, and the color as well is very like honest person. Please try to find this. If he look into this table, he can totally remember it. So, but a normal brand of human, I don't think that we can remember. But it is easy for you like to do the step. Let's say for the numbers, it would be like, I don't know how you're going to remember this, but for the numbers ABC over here is can be easy. Maybe you start with 41 or 65, and also over here, I don't know your creativity to remember, but I don't want to remember because it will be provided in your test and also exam. There is example or exercise for you to try. Please try to do it. Convert the string ASCII to hexadecimal value. Calculate the odd parity after you like converting it, and then you insert the MSP part. And after you already convert to the odd parity bits, you need to recalculate the ASCII value. What is the value? Of course, you need to convert back to um ASCII first, or maybe you direct convert to hexadecimal. So this is the answer. Oh, I didn't provide. Supposedly it's here. You can try to do like this example. You put the ASCII hexadecimal and then the binary, and you check the tables whether the question is odd, right? Odd parity, you add whether it is 0 or 1. It depend on the questions, the answer here. And you will directly get the new ASCII hexa value. So that is only for our module 2.b. Module 2b. There is another one to see. Maybe we're going to take 5. We will start back at 9 minutes. So we will proceed to our next module 2c. If you have any question, please just ask me directly, okay? Okay, already past 5 minutes. Let me continue. Where is Afan? Yiki, Alpha Rabi, Gen Jiahui. Okay. Let me ask Umar Hafiz. Umar. Umar Haziq. Umar Haziq. Okay, just to ask, okay, simple question. If let's say I have the number of binary number, how I'm going to differentiate that number to be positive or negative, just using binary. Just like maybe you already look into the modules, or in terms of your personal view, how you're going to differentiate positive or negative in binary number.
Wait, adapter, let me think for a while.
Not think. Let me check the notes for a while. Dah dapat jawapan dah?
I'm not sure about I'm not sure about my answer, but I try.
Okay.
So if like the binary is 111, and then we exchange it to we add 1 to the binary, so it becomes 000. So
Again? Okay.
yeah, do I need to repeat it again? So like you invert 111 to 000 because we add 1. And then the 111 will represent it as -1 in decimal. Is it like that?
This one you go take a look the second complement, first complement.
Yeah.
Okay, it's okay. So that is from Umar. Okay. We're going to look into our module 2C, which is under this part, we're going to go deeper on arithmetic operation. Like our normal numbers, we can like just add them. It's easy for us to add because we know if there is no positive in front, we assume it as a positive number. But in terms of, let's say it is negative number, and we want to add, let's say with 100, so we know this is negative. But instead, if we are playing around with machines, machine don't know about this kind of number, uh, computer only know, as I mentioned, 0101 value. So our binary number, we need to represent it to be with the signed number. It is easy for us to know for unsigned, because no need for us to like head it to things whether this kind of number is it positive or negative. But if As mentioned, it is a signed number, then you need to know, from 1010, how am I going to know is this number is positive or is number is negative? So last time, sorry, I eat roti. So last time, when we have learn on our GITS and in our module 1, I always mentions when you have 0, it's normally as off, it's also as false, it is what, low, or maybe inactive. And I mentioned, if you still remember, it always something that negative. And for 1, I mentioned to all of you, it is on, it is high, it is true, it is active, and etc. And I mentioned whatever one, the positive terms is going to be 1. But it is vice versa in our sign number. For our sign number, when we want to represent positive, we will have 0. When we want to represent a negative number, it will be play around with 1. So you cannot apply the one that I mentioned in our module 1. Sorry. So that is under arithmetic operation. Then after this, you're going to see how you're going to apply that 0 and 1 to your binary number. This is unique because you're going to play around. Let's say for the value of 10110, you want to add with 01101, let's say. So you cannot like simply add. Let's say this is positive number, okay? Maybe I have this 1 and 1. If you have like extra 10, the value will be totally different. So that's why you need to have like a method or approaches just to know whether it is negative or positive number. Because when you just add or maybe you do a subtraction, there will be a possibility of error. Normal sign number also, it's also will get an error. So that's why you will learn on like first, second complements, first complements to be play around with adding and subtraction. But later on, okay, so this is just an overview what you're going to look into the arithmetic operations. Now slowly, step by step, I had to read. Integer representation. Number can be represented as a combinations of value or a magnitude and sign plus or minus. Apa ni? When I read sometime, normally when I last time my friend will say to me, why are you always like fokus and termenung baca the buku kan? When I baca buku tu, when I read my books, I will like staring at, let's say there is a one sentences, let's say one paragraph, I will like staring the whole time, maybe like 30 minutes, because it's hard for me to read and direct go to my brain. I need to several time to carefully focus. I need to like numbers, okay, numbers, value, okay, magnitude, something like that. So that is my kind of person, because I really don't like reading. So you have unsigned integer. So you can try to read. You have unsigned integer and signed integer, of course, in terms of representations. And the magnitude is the value of the numbers plus minus, which is our normal numbering decimal number system. So you can just have that symbols to shows whether it is positive number or negative number. So for the unsigned integer number, there is no negative because it is unsigned. So always it is positive. So you're going to have the number starting from 0 until infinity. A bit can store unsigned integer numbers. If let's say this is on your binary, can store integer 0 to 1. A bit of 8 bits can store unsigned integer. Okay, this is the range basically. Your range. If let's say you have 8-bit, how many numbers that you have? So you're going to have from 0 to 255. Altogether, the numbers is 266. Uh, 256 for 2 the power of 8. But for the range, you need to minus 1. This one you can try to read and understand it carefully because it is not too important. Yet, still it will come out, also can come out and might come out to your test, which is find the correct explanations regarding unsigned integer number. Maybe so you it give you that like uh, a byte of 8-bit is range of, let's say, 0 to 256. Let's say it give you this. Is it correct or not? So it is incorrect. So where is the correct one? So maybe it is like putting to the power of 8. No, also. So the range will be, let's say, to 8 minus 1. So this is the correct answer. So you need to also understand the situation for unsigned number and also unsigned and also signed integer. So in terms of this is under decimal value, similar to here. When you have the binary number, we're going to have 0101 only. So this is the range. That's why you have the maximum. If you look over here, at bit 1, 2, 3, 4, 5, 6, 7, 8. All together at bit. There is no adding value you can put. So the highest numbers that you can have is all 1, isn't it? So if you convert this number, you will get 255. Similar to if let's say I give you an example, you have a range number of 2 to the power of 3. 3. Okay, 3. So you're going to have, this is the maximum possibilities that you can have, which is you're going to have 8 possibilities for numbers from 0 to 7. Why 7? You're going to have 0, 0, 0 until 1, 1, 1. This is the only possibilities number that you have. This is a range, and there is 8 numbers altogether. Just an example for you to see this one. This is too long. So if you add here, you will get 255. Still under unsigned number. Well, there is a lot of wording here. So the large number will be 1111, which is the one that I mentioned. It is 255, and the smallest will be 0 because you play around with binary, which is only 0 and 1, and you only have the restrict 8 bits. A words of 16 bits. Please make sure you still remember the nibbles, word, byte, bits. Then you know one word. This is one word. One word equal to 16 bits. Can store unsigned integer with this value. Oh, this one is too big because this is the range. And your total number is 65536. And what else? Because you have all together, let's say over here, one word, sorry. This is byte. So this is one word, you have 16 bit. You have this one is one byte, which is 8 bits. And this is the range. And the smallest is 0. And all together you will have possibilities numbers, which is from 0 to 65536 F35. All will be together this number. That is on unsigned number. The range of number, let's say you will be asked to find and calculate the range of number. This is the equations that you need. Normally you were given with the bit value like just now, and you just apply it here and -1. For example, going to see you were given find the range by representing of 10 bits. Of course, you just apply in this equation. So this is the range to the power of 10 minus 1. So you can calculate by yourself to the power of 10 what is the numbers, and then you -1. So your number will be from 0 to 1 to 1023. And all together you have all the number is 1024, including the 0. Upper bound and lower bound. This one is like a range. Of course, our lower bound for unsigned is 0. This one is tick because we didn't have negative number. Negative 1 is starting on the signed number. So for unsigned, it is similar also in the range. Similar. But instead, if we have like 0 until let's say 1 to 1023, this is your lower bound, this is your upper bound. So this is the equation that you apply, and this is the lower bound, and the range is here from 0 to 1 to 15. So this is just a normal apply. And there is also another example. No need for me like to focus more because that is very simple on the range. I guess range we already learned since our primary school, and only maybe in terms of like lower bound, upper bound, it is a new terms maybe. So I hope that it's easy for you to understand. When you have a sign, now we look into a sign number. If you have any question, please just interrupt me, okay? When you have a positive and negative number, which is you have sign, negative or positive, you cannot put this symbol to your binary system. Instead, if you want to represent 0 or 1, as mentioned, it is vice versa with what I mentioned for you, especially when you want to apply with the gates. Positive will be 0. negative will be 1. Slightly different with your gates, which is if you have like 1, it is on, which is positive term, and 0 will be negative. But for numbering, 0 will be 1, 0 will be positive, negative will be 1. And you will put all these symbol in front, similar to our normal symbol. We put 1 in front, we call as MSB. Example here, if you have this number and you want it to be positive, you just add another 0 in front. If it is negative, you will add 1. So this is referred as sign number. But of course, you're going to like you're going to also confuse if let's say the question did not mention. Don't worry, the question will mention how many bits that you have. Example that given here, change the following binary number to the binary representation. Normally it will mention how many bits also. This is the one that you need to remember. It's easy for you to remember. The positive is 0, negative is 1. For positive, okay, for the normal things that we have, we're going to have 100 for our 4. 100 is 4. And because it is a positive number, we add 0 in front. Similar to negative here, when we have 12, it will be 1, 8, 4, 0, 0. This will be your 12. But instead of this 12, we have negative in front, we will add 1 in front of numbers. So it represents as negative. So this is the first thing that you need to know. But later on, you're going to do first complement, second complement. Although you will apply all these, just don't confuse, because later on you will given the number of which is total in the equation. We provide 4 bits, 6 bit, 8 bit. So it's easy for you to know. In this question is like too general. You don't know whether you need to put like here, which is 5 bit or 6 bit. It is too direct to open, isn't it? So there is also another things, which is determine if the binary number is positive and negative. In this question, you can see it's basically shows you like the ball and also there is a space. But in test and also final exam, it's not going to be hint like this, but instead it's going to give you how many bits that you have for the numbers. Okay, for this side, of course, it's totally, you can see it is positive number, this one is negative number. You just need to convert the value. For this one, 0, 1, 2, 3, 4, 4 is 16, total is negative 17. 3, negative 3. So you can try to calculate the value and you know whether it is positive or negative. Sign number representation. Okay, so over here you understand, right? Because after this you're going to go deeper and deeper, especially when you want to go for your second complement, first complement. Okay, why you need first complement, why you need second complement? As I mentioned, when you have the numbers for the magnitude and sign, simple representation, the one that you learn here, when you just add these two numbers, let's say you add, you're going to get sometimes it will be error, which is in front you will get 1, let's say, but it is supposedly to be positive number when you add together. Just give example, okay? So it is error. That's why later on, instead of just a normal simple representation, for adding, for subtracting, you need to have first complement and second complement to avoid this kind of error. Maybe you can try to play around with numbers, then you can see, oh, now I find the error. Where is the part that's repeated error? Before we go proceed to that, first complement and second complement, for our sign magnitude representations, sign and magnitude similar to our unsigned number. We're going to have range, lower bound and upper bound. It's slightly different because for our unsigned, our lower bound is always 0 until to the power of n minus 1. This is our range for unsigned. But for the sign, you're going to have lower bound as minus 2 and minus 1 minus 1. So this is the equation for lower bound. While for upper bound, you're going to have 2 and minus 1 minus 1. This is the upper bound. You need to remember the equation. So it's slightly two things that you need to remember. But for the unsigned, it's very easy for you, right? Where n is a total bit, this one you know already. Let's say you can see the example given. You have this one is just represent the positive and negative. For positive, we're going to add another 0. For negative, you're going to get 1 here. So a negative number has same magnitude with width as responding positive number, but sign is 1 rather is 0. So this one is 1 for the magnitude of negative. Another example, let's say you have 4-bit integer. You need to apply into the lower bound, upper bound equation here. So you will get 2 the power of 4 minus 1 minus 1 minus again for lower bound. And for upper bound, you will get 2 the power of 4 minus 1 minus 1. So you will get to the power of 3 minus 1. What you will get is 7. And over here, you get it negative. So let's see over here how basically it look like. So you will have the range of -7 to +7 because it is a sign number. Your range is much bigger. You have positive side from +7 until 0, and then you will go back to -1 until -0. You can see over here the value. So basically you have like this. Is 0, 0, 0, 0, 0, 0, 0, 1. Okay, let me show you where. Okay. First, of course, you're going to have the value. If let's say you have 4 bits, right? You're going to have 0, 0, 0, 0. In front is your whether it is positive or negative number. Then you will have 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 0. Okay, until here first, you will have the value of 0, 0, 1, 2, 3, 4, 5, 6, 7 in decimal. And you will notice it give you directly integer for bits, and this is the value, this is the symbol of whether it is positive or negative, which is the sign, and this is the magnitude. Magnitude is your value. This is sign, this is your magnitude. And when you can see over here, this is all 0. 0 means positive. So you have the value of positive, 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 positive. Because this is 4 bits, you know that you have 2 to the power of 4, you have 16 possibilities altogether. So you're going to have also, I continue over here, okay, 1000, 1001, oops, sorry. Okay, all together, when you continue, as I mentioned, this will be 8, 9, 10, 11, 12, 13, 14, 15. All together, including the 0 part, you're going to get 16 possibilities of number if you have to the power of 4. This one I already repeat several times. This is not the magnitude value. This is just the one that supposedly you have. Which is from 0 to 16, 15. And where is your sign? This is your sign. This is your magnitude, which is your value. You're going to see for this one, it is negative. But as I mentioned, this is not your value of your magnitude. This is just for you to know after this value 0010, you're going to have, this is 7. You're going to have 8, 9, 10, 11 until 15, 100, and etc. So over here you have this magnitude value is 0. This one is 1. And that's why you have -1, -2, and continues. So for 000 over here, of course, you're not going to like continuous all again because it is similar whether it is negative or positive. This is your range. +7, -7. If you have another versions of number, let's say 3 bits, you can do the same, which is you put 000. I show here 000. This one is your magnitude, this one is your sign, 001, 1011. And then you go beside, you will get 01, and then this one will be 1, 1011. So you have negative. What your number will get, you will get the range of +3 until -3. The range. This is positive, this is 3. This is negative, this is 3. So it depends on the question, but it is not going to be directly asked like this. So another example, you're going to see express the decimal number +25 and -25 as 8-bit sign. So binary numbers is a sign magnitude form. So in terms of magnitude form, you need to have 25. Let me try to convert 25. 32, no. So until 4. We have 8-bit is okay. You're going to see that for 25 you have 1, 16. Congak pun tak lepas ni. This one is 16. Siapa yang WhatsApp banyak ni? Oh, my student. Someone help me to convert 25. I don't want congak anymore. Is it? Kenapa tak nak tolong langsung ni? Aduh. This one is 25. Betul tak? In binary.
I think so.
I think so. You don't have
Yeah.
calculator.
No, sorry.
Okay, in binary, you will convert directly if let's say 25. Only the magnitude you look. 25 will be 11010. And when you have positive and negative, for positive, although you have like 8 bits, now you have 1, 2, 3, 4, 5. 0, 1, 0, 1, 1, 1. So you need to add another 2 bit 0, 0. This one, it will be positive. While for negative, you need to add 1, 1 in front. Let's take a look at the example. This is your magnitude value, including this part, which is, this is your sign bits, which is 0, you put in front over here for the positive number. While for the negative, I put 1, 1, sorry. The magnitude will be at the most MSB, which is 1. The 1 is all 1 is later on, you will look into the complements. So here you're going to see this is your magnitude, and you will add the sign number to be as a 1. All together will be 8 bits. So that is the only difference between positive and negative number, only at the MSB side. And of course, in your question, you will given directly the bit sign number, how many you will have. Okay, sorry, my student need to submit the title today. Okay, now our complements of number. Then, as I mentioned, okay, you already know the sign, how you're going to apply positive and negative. You're going to apply 0 in the MSB and 1 to the MSB for negative. And we're going to have the complements, because if you play around with numbers, when you adding positive and negative numbers directly from this system, sometimes you will get an error. You will get like, suppose you get positive, but the value in front is 1. 1 is negative, right? So maybe I give you example. I don't know what example I can give. Let's say you have 0, 1, 1, 0. And you add with negative value. Well, 1 is negative. You have 1. Maybe you have over here, what numbers you have? 4, 5, 4, 6. This is negative 1. This is positive 6. Supposedly you will get positive 5, isn't it? Instead, if you add directly over here, this one is adding, you will get 0 plus 1, you will get 1. 1 plus 0, you will get 1. 1 plus 0, you will get 1. And after that, you will get 0 plus 1, you will get 1. C, you will get negative. That's why you cannot directly apply this method in terms of addition, in terms of subtraction, because you will get error. You cannot apply directly. This is the purpose. Later on, you need to have complements for your arithmetic operation. But of course, you need to know how to convert first, because you need to apply it later on in our complements. So we're going to learn first complement and second complements. Then you know why you have that first complement, second complements. You can read all the sentences here. Okay, for our first complement, we need to convert any bits of 0 to 1 and any bits of 1 to 0. This is the method for first complement. Before you can jump to second complement, you need to do first complement first. And again, as I mentioned, why you need to learn this first complement, second complement, because just now I already give you an example. You cannot directly add sign numbers. You cannot add directly because you will get an error, like the one supposedly you will get positive, but instead you will get 1 in front, which is represent as negative. So that's why for first complement, what you need to know is if you have any numbers like 10101100, okay, how to convert for first complement? You just change the value. 0 will be 1, 0 will be 1, 1 will be 0, 1 will be 0, 0 will be 1, 1 will be 0, 1 and 0. This is my first complement for this number. Let's say this one is, I don't know the magnitude. This is negative numbers, of course. So whatever number it is, if I want to convert for first complement, this is my answer. So that is a range for lower bound, upper bound. This one, you can like similar to, quite similar to the sign number. So I'm not going to touch because it is basically no question to ask about range for first complement. Supposedly, we will like apply the range in like magnitude in final answer, which is after second complements. So example over here is given. If we have positive here, we will apply 0 here, of course. Then we will convert it to using our first complement. We will get like 1 0 0 0 1 1. This is just for you example, basically similar to here, how you're going to apply the positive and how you're going to apply the negative part. For negative, you're going to do the first complement. You're going to change the value. First, you're going to have negative in front here. Assuming 7 bit 1 2 3 4 5 6. Okay, you have 0 0 1 0 0 1. Supposedly it is 0 1. It's okay, you go for here first. Okay, this is directly. You're going to see when you apply, you change 1 1 0 1 1 0 1 1 0 1 1 0. When you have this kind of number, Supposedly, when you directly change using your first complement, you will get this one. But instead, you have this kind, because you have 1, 2, 3, 4, 5, 6 over here. You need to have another 1 in front to be your negative number, right? So if you normally change using a magnitude numbers, you can just adding this part. But when you want to apply the first complement, no need for you to add directly the value of 1. Instead, you just left it as a 1 in front to be complete as 7 bits number. Normal versions, when you have this number, when you want to complete with the 7 bit, you have this number. Instead of you use the sign magnitude, which is you will add 1 for negative, 0 for positive. You cannot just apply that because you want to play around with complement, first complement, right? So for this number, you have 0, 1, 1, 1, and then you have 0 here. Over here, if you have 1, 2, 3, 4, 5, 6, this one is 6 numbers. If you have here for positive part, it's okay. We will look into, you can see positive number represent the same way as a positive sign magnitude. So you just add another 0. There is no changing for the positive for first complement. For negative, you need to use the first complement. For negative number, you need to use the first complement, which is no need for you to look into the sign numbers like you learned in our previous slide, which is you need to add 1. No need for you to do that. Instead, you just complete the value to be, let's say, if ask you 7, you just add 7. 1, 2, 3, 4, 5, 6, 7, and you completely change it using the first complement. If it is 0, it will be 1. If it's 1, it will be 0. So this is your first complement number, or you will know, okay, this is negative number. If let's say you have different number, I give you, we just pick this one. Let's say this is 0, 1, 1, 1, 0, and we have the negative number here, let's say, but it is 1, 2, 3, 4, 5. Let's say we want to have like 6 bits. So we just add another 0 in front, then we convert it to be first complement. I just give example, okay? Assume this is negative number. We just get the answer like this. So we know, okay, in front it will be our negative number. So this is first complement. You only apply for the negative number. No need for you to change anything in a positive number. You just do a similar things with the sign magnitude, which is you learn here, which is you add the 0. Now you can see for 4 bits number, let's say you were given with the value for the first complement for positive, you just need to add 0 in front. You add 0 in front, you add 0. So you will get this as a first complement for the value given. And when you apply into negative value, you will get 0, 0, 1, negative. How you're going to do is you just need to change it later on because our 4 bits, right? We have 0, 0, 1. Complete it to be 4 bits. We have 0, 0, 0, 1 for negative 1. How are we going to know it is negative? We apply it first complement. We just change the value of 1 to be 0. 0 will be 1, 0 will be 1, 0 will be 1. And our first complement is this. And for value of negative 2, negative 2, 2 will be 1, 0. And then if we have 4 bits, we will have 0, 0 in front. And we need to know, okay, this is negative number. How we going to do? We just need to convert it to be 1, 1, 0, 1. We just convert the value of 1 to be 0, 0 to be 1. And etc. You just need to change. Wait. Okay. Okay, for this part, you can see under our 7 here, we have basically 1, 1, 1 for 7. But for negative, we need to know, okay, this is negative number, but we have for bit, we put here as a 0. When we just apply it, we change is the value 0, 0, 0, 1. So this is the first complement for our negative 7. So basically, it's how you're going to do is similar to all the number system. And you can try to do the example. I hope that we can finish it. Maybe after this, I have 1 hour break. I'm going to record the video for second complement. And until the rest, then you can watch it. Later in our class, we just discuss on our second complement because our second complement is for adding. So adding, we need to do a recap. We still need to learn together. Okay. So any question for our first complement? So if there is no question, if there is no question, we will end up our class today. I'm going to share again the QR code for those who just joined us. I'm not going to share it into the e-learning. So for the rest, you can leave and please stay safe and goodbye.
Thank you.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you,
Bye-bye.
Doctor.
Thank you so
Thank
much.
you. Bye.
Thank you, Doctor.
Okay.